Okay, I think we should start. It's 10 o'clock sharp. I came here to tell you about the instruments and tool that we use. It has to do with databases. First, I tell you words about myself. My name is Nikita, and I'm co-app of the Arcadia company. I came from the south. I've been doing this for 5 years. Of them, 3 years, I've been working in Arcadia, and I've been working with a client who is a clinical test provider. Provides products on clinical testing. It has some interesting points that I will tell you more about now. We have the following context. We have a SQL Server, a big warehouse, which has a lot of data coming into it on clinical trials from different sources. They're all inside, processed there by ETL, and can be uploaded later into a smaller database to be used by some other tools to complete some concrete task, or the client can sometimes provide an API for their clients. To do this, we use special procedures, so a lot of different codes that we use inside this bank. This is something that you need to test, or do you really need to test that? Why? What's it all about, and what are we to do with this? Basically, the database code follows the same logic, and it can be susceptible to the same bugs. Usually, people are given the same graph. The later we find the bug, the more expensive it is for us to fix it. Usually explained by the fact that you need to go back on many stages and determine where it appears. In our case, it's much more relevant if during the processing of the data using the EQL, you have a bug or hidden bug, and it can go through many changes, and you need to find a place where the ETL was broke down for the first time, and also you can find some other data that was broken. There's also very some specificity to it. I mean, it's not about the toys, it's about the health of people. So if we do really need this, we need to decide whether to test it automatically or by hand. Nobody actually does it by hand, but in this case we mean the testing using units or unit testing. It's very seldom that these things are done not automatically. As a bonus, you can see assistance in code documenting. Basically, this is, in a nutshell, how it looks like. As a huge number of certain marks, you need to understand the logic all at once. But I need to note that as the code difficulty grows, this effect can wane. Also, from the side of the client, we can have some guys who can spontaneously merge, and if you put tests into the CI, this would not happen. Probably the first test that I wrote using this framework, there was some spontaneous merge and some bugs came out on the surface. If we decide to automate this thing, we need to solve this following problem. What do we use to test it with? We can use SQL part solutions in the database, or we can use a separate tool that can understand the request. If we talk about SQL powered solution, the benefit here would be that we don't need any additional tests. It would all be inside, and if everything changes, the test will be kept inside. There will be no additional questions to you. For you. Also, we don't need help from the programmers. If you have, like me, a tester who knows the SQL and database, they can start doing this kind of job. Or you have DB database admins, so you can delegate this task to them. They can solve this quickly. Also, the certain fakes can be easily applied here. In here, they can be easily applied by the developers of the tool. It depends on the database, but with SQL Server, we can have CLR that can be use advanced fetches. The main drawback is the necessity to install some additional objects in the database. But if it's a tested database, why would this bother you? So it's not really a problem as such. What kind of alternatives do we have? On the first line, you can see the tSQL that I'm going to tell you about, and a number of solutions like tSQLt. Not all the information is up to date on this slide, but the first line solution is what we really support. So tSQLt is something that is really advanced. You can integrate it without problems. Integration test can be drawn back, reversed. All other solutions not so that cool, but TST has a good search libraries in many ways and better than tSQLt. So if you don't really want to use tSQLt, you can pay attention to the last one, TST. They are not all well documented. One was smiles missing here, but as for the documentation, some things are missing here. But on the whole, this not all parts of it are live. The Google Trends supports this picture, confirms this picture. You can see that tSQL unit is really struggling, and TST is much a more interesting solution, but TST is an abbreviation which can mean a lot of parts, a lot of things, from comic group to a certain church. So you should not really believe in this trend. Non-tSQL powered in its alternative is a very interesting. Let's go deeper into DB. Feed is an interesting tool that can be used. Fitness approach. They don't like the SQL unit. So in the first article, they describe why you shouldn't use XUnit. And another interesting tool like Slack, but Slack is quite controversial. They recommend using the tests on Ruby. So if you need to make this choice, you need to understand that there is some ready-made unit testing frameworks that could be used by you by additional libraries, which can also be used for these purposes. As to the documentation and manuals, it's a well-developed, and community is also friendly. Google Trends showed me the Google Fit. Another trends and descriptive you can see is of some interest to the people. A few words about tSQLt. It's a framework testing solution. It's supported by SQL Server from 2005 and second service pack. I didn't go very deep there. I didn't check us. In our deep server, we have the Pro version from 2012, and I use the 2017 version. It uses all the benefits available. I'm a tester and managed to complete this task. It's an open source license with a patch 2.0 license. You can fork it, but we know that it doesn't use any bookmarks. How does it work? If it works in database, we have test class and test cases. Test case is the regular procedures of cycle. So test class is the regular scheme. It's different from other schemes in the way that it needs to be created with a framework. So you cannot simply create a scheme. There's a procedure that can be completed before every test case. So we prepare a general setup for SQL class. We don't need a teardown procedure. This feature with a reverse and transaction, when it reverses at the end, is not necessary to us. It's not needed. We can complete a concrete test case. We can launch a full test class, and we can run everything at the same time. upload of data. As a result of the launch, we get this picture. It's very clear and obvious. You can see. You can get a table at the end, which also refreshed after each launch. You can see the data from the latest launch. Also, HTML output. This works fine. Everything you desire. You can install this tool in a second. You can activate tSQLt and launch a script. You would create a test class and create test cases. Then goes the worst part. That's something we came across, good and bad examples. The best example is CSV SQL. One of the clients asked us to provide to them not the API, but opportunity to upload the CSV with some data. And also they added some interface, and all the data is kept in the table as it is. And we get the following data. This is the request, and brings back the huge result set. In this case, I use this example where we use the general data about the testing. There are lots of columns, but let's examine one of them called clinics num, about the number of clinics that participated in our trial. We have 2 tables, for example, the trial and the clinic, number of clinics we just count. Basically, we'll be testing the following request. This number in a joint table will be calculated. For concrete sedative, we shouldn't forget about the grabs. We have a huge number of columns, and count is not the only thing we get. How do we test this request? This is how it works. This is how we do it. Using the fact table, we can work with tables. What do we get? We just rename initial tables and create the same without constraints, without triggers, without data. We get this STM. We will not see this kind of data. As a person who worked a lot with web applications, I came across this quite often. You simply need to put in a number of things. I need to process a number of constraints, but we don't need this now. Here, we need to input the concrete data for concrete tests. So we use this. We put in 2 clinics. We have the test data here. We added it. We need to get the actual expected and compare the data. We use a statement from one of the tables and run it. After we do it, we launch it in the actual. And here we have all the data that we're interested in. We do the expected in the same way, but we make a small table with clinics. Now we add the data we need. We can compare the tables to be more exact. We can compare the content. This is how it works. It compares only the columns that are present in both cases. We have a huge number of columns, and in columns where it follows its own logic, and a huge number of work that needs to be done. And it could be put in one test case. We need to leave this test case small. We are enough for it's a double-edged sword. If we create actual and automatically generated number of columns, you can just miss appearance of the new columns, and you need to write a separate test case. You need to consider this. Point S to the assertions and table metadata. They have 2 brothers that work with metadata. Assertical tables works with metadata of the tables, and this long thing here on the screen works with results of metadata. We shouldn't forget about the constraints. You had a trial, a clinic, but a clinic column will have a foreign key. It's the same logic, just like everywhere else, when it also needs to be checked. I suggest you use the follow option. The same, we use fake tables with not a single constraint, and then after we apply constraint, we bring back the constraint we need. Again, we can test it in isolation, only what we need, not to be worried about other constraints. We bring it back, and now we need to check the fact that we're not, we cannot insert what we mustn't insert. But use the exception, we introduce number of exceptions and wait. There are three parameters that I showed you. In fact, there are a huge number of them, and all the potential parameters that existent in the SQL Server exceptions. The gentleman said we receive exceptions, it's processed by the processor, and then the test case passes. Same mechanics is true about the triggers. Same fake, apply trigger and see if it works correctly.
Now, let me tell you more about this example. So we have a pack of some saved procedures, services, and many other things that want to work with the data. And we need to understand what the order will be to launch them. We need to differentiate the access to them. For that, we have this device. It's a pack of all the procedures. I'm not going to cover all of them, but here you can see a color light signal. So it's like a job starter. What does it do? It does several things. So there is a process, a list of all the processes that we theoretically launch, and there is Proc Status, and this is another list of processes with information of when they were started. Job starter, if you push it, it analyzes the list. If you are interested in a process, it launches it. If the process is in the list, but there is a 0 next to it, we do not launch it. It's a new thing that you cannot launch for now. Proc Status is where you can check if you already have it. So we have already checked it, and suddenly you see that it suddenly was launched, and you need to check if it was suddenly launched, and you don't need to launch it for the second time. If everything is fine, if every check is done, you see in proc if something is wrong, you do yd minus 1 because nothing was inserted, you don't add anything, and send an email to admin. So you need to check three things. What about the situation when the process is absent? The spec table, it's not so needed here, perhaps, but anyway, it will make our life easier. First, we believe that there are no data. It will be seen better. You can insert everything here. In case of Proc Status, you can easily check if the note is there or not. If you want to check that something is sent somewhere, in this case it's a procedure of email sending, you can create this kind of mock spy procedure. What does it do? It replaces the existing logic with its own logic, creates a login, creates a table, ID, procedure, subject, and message. So here are the columns. ID just the number of inquiry and other stages and processes. So you can insert it and you can check it. And if you want, you can add additional logics there. If you want not only to do the login, but also other things, you can insert it. But in our case, we don't need it. Then we implement the procedure. First, we create the variable, and then we can make a check. Check number 1, send in a letter. Here we see that in the log there is a note. It means that everything was performed correctly and the letter was sent. If it wasn't sent, then with the help of fake procedure, we analyze the case. If you have your own constructions, some special constructions that you cannot cover so easily, you can do this. Also, you can add additional parameters, but in our case, we decided to simply check the fact of sending. Exec table is something that you can help you. That can help you. It's just one line that gives you an information that the check was performed. Here we are absolutely convinced that it was done, and at the end of the day we get -1, and we see this information in proc status. Simply a comparison of the variables. In assert equals, we have different names. Out of the names, it's clear what they do. Assert equals 3, where it's a special procedure which works with SRMax. Other procedures work with SQL variant, but Max doesn't belong to it, so we need to create a special procedure for that. Spy procedure. It has a brother, fake function. If you need to add additional simple logics, you can do so. These are the features. The list is not completed. Not everything is smooth there. We have some pitfalls caused by SQL Server and their limitations. The main problem is not this dish, of course, but the rejection of transactions. If you eat the whole dish and you think that something is wrong with the food inside, you won't take it out and eat other things. Same here. If a transaction is performed and if transaction is declined, everything is declined, including external transaction. In our case, it's more difficult because we have an external transaction which creates a procedure, and if in procedure you have your internal logics, then at the end of the day you might have problems with the extraction of data. What kind of solution do we have in this case? We don't create fake transactions, we just check if we are inside of transaction or not. If we are already there, we do save point. The difficulty, there is additional difficulty. Sometimes a transaction becomes uncommittable. Then you cannot commit it, and you cannot do the set save point. It becomes more difficult, and the construction you have looks like that. We check if we are inside of transaction. First we take a variable, then we check it. If we are inside of transaction, then we suppose that it's a transaction we tested, then it's save point. If not, then we start the transaction. We do something useful if everything is fine. It's a regular launch. We don't care about this transaction. If something goes wrong, there is exception, we go to trial. Then we can check where we can go back to. We have an opportunity to roll back to the save point if it is committable. And if transaction is fine. Otherwise, you need to do a total rollback. This is the main problem. Additional thing, if you use fake table, you can face a situation like that. It's trial, it's clinic, but if you do only one table after two, you can have a problem like that. We won't be able to insert anything inside of the clinic because foreign key is still there, and it is a reference to the table. So you can either fake everything or don't fake anything. Depends on your taste. We sometimes reject fake tables. We create a table, a database with necessary information. But it all depends on your taste and context. Spy procedure. You won't use it on the systematic procedures. You need to create some kind of layer between them. In case of our color signal or starter, it was caused by our internal manipulations, but be ready that if you need to track these things, if you need to track the reasons, you need to create additional layers just for the purpose of trial. Evident moment that I want to talk to you about, there is no spy function. SQL Server works as a toothpaste. You apply some effort and the toothpaste goes out. There are no side effects. it's an interesting thing you need to remember. What are the advantages? To my mind, you can start working with it really quickly. Quick setup, 5 minutes maximum. You can get familiar with it quickly. I asked my colleagues and they told me it takes about a day to understand how to get familiar with it. In my case it was a bit longer, but anyway, one working day is enough. And the quick insertion in CR in a couple of hours. As far as functions are concerned, there are a lot of functions. Of course, it's a subjective point of view, but from my own experience and interaction with the colleagues, I can tell you that it makes your work easier. A lot of functions that covers a lot of cases in real life. And documentation. So you need 1 day to get familiar with it. And this instrument is not so difficult that you need to dig in. But anyway, documentation is there, it's logical, and it's clear. And Redgate is a large player in this area. It's called SQL Test. It's an official SSMS plugin for tSQLt. And they also helped with dev environment. But I'll tell you about it later. It's a nice moment. What are the disadvantages? I believe the disadvantages are related to technical things. Fake and timed tables. It is impossible to fake timetables. There is no comparability with the SQL Server 2016. You cannot access the external databases. You cannot refer to them. It's not a really big problem, but anyway, it's a disadvantage. And here is a doubting smile about documentation. It's useful and it's clear, it's very transparent, but some things are really outdated there. They say that they create an archive, but in reality we don't use it anymore. There are some cases that are not really useful, might be changed. But it's clear why. I think the main problem of this instrument is that it's partially abandoned. In 2016, the active development stopped, then people started to commit something. Last year, Sebastian Main, who is the main developer, said, that's it, we are working, Redgate helps us with the environment, action will start soon, but on the 2nd of March this year, Sebastian said that action didn't start it. However, they commit something in 2016 that overall programming was finished. Then they started to do some minor things in 2018. In 2019, there were some changes in chemo tests and so on. And the last commit was this document. They say that they will build it till the end. Hopefully, action will start soon. Let's wait. And don't forget about this thing. In Server 2017, there is a server level flag, a CLR strict security, which makes the setup of CLR procedures more difficult, and you have a chance to face it. With me, I had a local server, I didn't have any problem. It could be one of the pitfalls, and hopefully developers can resolve the problem at the level of framework. It's not easy, but in GitHub there is an ability to do so, but for now they haven't done it. Anyway, it's not a blocking problem. Summarizing my presentations, I want to tell you about the analogs. They're not really difficult, but if you like such an approach and if you want to try something, use post-GRA-SQL, so you can be in actively developed, latest commit 2019 in active development. Right now, it's a functional instrument. It has a small brother, MyTab, and MySQL. Absolutely the same. My type is similar to the previous one. Functions are not so rich here. There are less procedures, but they say we want to take more from PGTAP. We want to take more functions from PGTAP. And if you are lucky enough to work with Oracle, then you have a great instrument, UTPL SQL. It's been super actively development, a lot of comments, a huge documentation. It's a really powerful thing. I believe that if you work with Oracle, you need to pay attention to that. And in conclusion, I would like to give you two main messages. First, the fact of code testing is an important thing. And if you don't have tests, perhaps you need to think about it. Think about using them. And if you are lucky, like me, to work with SQL Server, then I would like to offer you such instrument as a tSQLt. And if it's not 100% winner, it's one of the best instruments out of all you can take in the market. Thank you. It's up to you. That's it. Do you have any questions? And here is my QR code and my contacts. Hi, Nikita. My name is Alexei. I have two questions. First, we test only what we save, but users use microservice. So what they do should go to some kind of microservice and go to the consumer, which means that we need to do two tests. First test, as you say, we test what we keep and what's written in PD. And second test, we need to cover the work of microservices. Don't you think it would be more logical to write down the tests at microservices? Because there might be some problems there. And if you have a problem in PD, then tests that cover microservices will cover the work of the archives. And if we write such tests at Java, for example, we'll do a driver for a base. We'll change some figures there, and we will refer to microservice. What about that? It's my first question. And second question, if you migrate from MySQL to Postgres, all the tests you wrote there, you need to simply throw them away. Another question. And second question about polarization of the tests. Is there an opportunity of tSQLt to make parallel tests? How many tests do you have in your team? How long do you make them? What is the duration? And do you have any problems if you create fake tables? I have never worked with tSQLt. But let's say you have two tests with two fake tables with the same names. Will it be a problem or not? First question is, don't you think it would be more logical to write down tests at microservices? At my first question, because you will cover everything, the whole chain. I understand your point of view. Okay, and the second is polarization of tSQL tests. First question, microserver and so on. I believe the levels will be different. This is all about testing. It's the work with the code. And in case of external units, maybe it will be closer to integration. I think these things are different. It all depends on the context. Perhaps in your particular case it would be better, but in our case the context is different because you need to choose instruments according to your needs. As for polarization and the speed, I don't really know what to tell you. We haven't worked with that. As far as the time, the duration is concerned, I haven't checked it. I know that it's not super fast. It doesn't slow down the deploy. I worked only with a part of warehouse. It's a big part of the software. It's only my subjective point of view. I wouldn't tell you that it's super fast. Hi, thank you for your talk. My name is Alexei. My question is like that. Have you tested replicas with this framework? And how many tables have you tested in foreign key? How big is the database product? Is huge. We don't really test foreign keys and constraints. Why? Simply because this part of relations between the tables starts with the client. They do it. Sometimes you see really strange things there, but this is what they want. Our main job is to work with the logics and warehouses. So for foreign keys and constraints, we don't have any tests for that, even if we have them somewhere in the future.
Good morning. My question may seem to you quite crazy, but how did you decide to test that in the first place? Well, it wasn't me. Well, it started a long time ago. Unfortunately, I cannot tell you more because the guy who was responsible for choosing this tool and many other things have not been with us working on this for many years now. But at the time, all the procedures had a huge number of code and a huge number of sheets, and we decided to apply test because the logic was not always clear to everyone. So the test and the client's question were part of the business. I cannot tell you more. I tell you details. I don't know, and like my friends don't really remember. I have an organizational question to you. You have a test plan, and you launch them. Do you test them one by one? No, we have a server. Therefore, the question: do you launch it at the database, already created, ready-made database? But no, we put separately a database with the test data. This perfect table that we gave up partially. Yes, it has some data, and test case is applied. So basically, you don't clean database of tree tests. You have a number of scenarios that I understood it correctly. So you focus on the transaction reversal. I think it's a great tool. So you do it using during the fail and successful situations. This is your point basically. Yes, we do it in both ways. It's processes everything and writes reports. Thank you. Another question from me. Did you think of putting all the logic from outside of database into the microservice or something like this? No, we didn't think about this option. I think it's a serious step. We should discuss it with the client, but we never thought about it really. This case would be unknown. Sorry, I cannot hear him. Well, but it's an interesting thought. I think should be the last question, but basically you can talk with Nikita in the corner. Good morning, my name is Arina. I have a question. If, for example, you don't have time to launch database and production, what do you do with testing of the production database? For example, in the company that I worked in, we used Zapex. We formed some GET requests, and we followed the work of and receiving data from the database because everything just went into production. We didn't have time. What do you do with this? We don't really cope with this. We never really came across this case. We have a test environment don't work in production directly. We have a separate stage of testing. All this test data is stored data along with the test cases. So who do you choose? Who do you choose to give a token for a baseball cap? It's a good question. I think I'll give it to this people. Thank you very much.